The year is 2041. Global warming has made the Earth's average summer temperature 104 degrees Fahrenheit. To combat the heat, McDonald's has added a new supersized item to their menu, the McBlizzard. The McBlizzard is an extra-large snow cone with a size of 20 centimeters in height.
You will never be satisfied. I will never be satisfied.
This massive snow cone is constructed by a machine. To check if the machine is working properly, workers will calculate the ratio between the rate of change of the radius and the rate of change of the height. This ratio needs to be within a range of 1 centimeter to 10 centimeters and 2 centimeters to 10 centimeters if the machine is working correctly and efficiently. They always check the machine midway through production when the height is 10 centimeters. If the volume is changing at a rate of 2 pi centimeters cubed per second and the diameter is 1/3 the height, then when the worker checks the machine, will they report that the machine is working or not?
So in the problem, we are dealing with a snow cone, and so the formula for the volume of a snow cone consists of 1 for the right circular cone and a hemisphere. So V equals 1/3 pi r squared h plus 1/2 times 4/3 pi r cubed. We're also given the rate of change of the volume with respect to time, which is 2 pi cubic centimeters per second, the height, which is 10 centimeters at that point in time, and that the diameter is 1/3 the height. So first we're going to condense the volume formula. So the first step we would do is multiply the sphere formula by 1/2, which would give us pi over 3 times r squared times h plus 2/3 pi times r cubed. Now, since we have two variables, we need to express the height in terms of radius. So since the diameter equals 2r, which equals 1/3 h, then h equals 6r. So now we plug in 6r where h would be, and when we further condense it, we get 2 pi r cubed plus 2/3 pi r cubed. And we can add those because they have like terms, so the final formula for volume equals 8/3 pi r cubed. Our next step is to find the rate of change of the radius with respect to time. So first, we'll look at our givens. The rate of change of volume with respect to time equals 2 pi cubic centimeters per second. The volume formula equals 8/3 pi r cubed. And we'll proceed from there. So the first thing to do is to differentiate the formula for volume. So dV dt equals 8/3 pi times 3r squared dr dt by power rule. The next step is to plug in your dV dt. So 2 pi equals 8 pi r squared dr dt. So dr dt equals 2 pi over 8 pi r squared. Now, we know that h equals 10 at this moment, which equals 6r. So r equals 10 over 6, which equals 5 over 3. So dr dt now equals 1 over 4 times 5 over 3 all squared, and which equals 1 over 4 with 20 times 25 over 9, which equals 1 over 100 over 9, which is 9 over 100, which gives you an answer of 0.09 centimeters per second. Previously, we found dr dt, which equals 0.09 centimeters per second. We still have the volume formula, which equals 8/3 pi r cubed, the height to radius relationship, which is h equals 6r, and the dV dt, which equals 2 pi cubic centimeters per second. So step 3 would be now to find the rate of change of the height with respect to time. So you know that h equals 6r, so you can find the relationship for the radius, which is r equals 1/6 h. Now, when you have the volume formula, substitute 1/6 h where you have r. So volume equals 8/3 pi times 1/6 h all cubed. So volume equals 8/3 pi times 1 over 216 h cubed. Simplified, that means that equals pi over 81 h cubed. Now you need to differentiate your volume, so dV dt equals pi over 81 3h squared dh dt by power rule. Now plug in your value for dV dt, which is 2 pi, equals pi over 27 h squared dh dt when simplified. Now dH/dt equals 2 pi over pi over 27h squared, which equals 2 times 27 over 10 squared, which equals 54 over 100, which equals 0.54 centimeters per second. In our fourth step, we have both rates of change. So dr/dt equals 0.09 centimeters per second, and dH/dt equals 0.54 centimeters per second. X is a ratio which represents the rate of change of the radius to the rate of change of the height, which needs to be in between a range of 0.1 centimeters per second to 0.2 centimeters per second. So the ratio which equals x equals 0.09 over 0.54, which equals 1 over 6, which is approximately 0.1667 centimeters per second. So since this value is in between the range of 0.1 centimeters per second and 0.2 centimeters per second, the McBlizzard machine is working properly.